Equations 3. A rectangular beam made using Fc prime equals 20 megapascal and Fy equals 415 megapascal. B equals 250, H equals 100, and AS is 325 millimeter bars. Use 65 millimeter for the effective cover of the reinforcement. When we say effective cover, it means that this distance is from the face of the concrete towards the center of the reinforcement. So that is the meaning of effective cover. What is the depth of compression block? The moment capacity of the beam comes from the couple created by the concrete and steel, no? Ayan. So ito yung force na nakikreate ng concrete, and then ito yung force na nakikreate ng tension steel. Of course, to maintain equilibrium, kailangan mag-equal yan. So doon mag-i-start yung ating equation. But first, we have some properties that we need to compute. First is effective depth, H minus effective cover. 500 minus 65, we have 435 millimeters. We start with C equals T. So the force in the concrete, we stress the concrete up to 85% of the Fc prime, and then we multiply it by the area of the concrete being compressed. So that is equivalent to the rectangular block. Okay, so that is A. A is the depth of compression block for this distance. And then B is the width. So equate natin sa force ng steel, which is ASFY. So makakompute na natin yung A. That is 143.7971637 millimeters. In order to check that this value of A is correct, so we have to verify our assumption that the stress in the steel is 415. So let us check first for the stress in the steel. First, we need to compute the depth of the neutral axis. So the relationship of depth of compression block to the depth of the neutral axis is A equals beta C. So how do we determine the beta? Here's the value of beta based on codes. Ft prime is less than or equal to 28. That is 0.85. Fc prime is in between of 28 and 56. So ito siya. And then if Fc prime is greater than or equal to 56, so the limiting value is 0.65. The value of Fc prime in our problem is 20. It will fall into this category. So we have 169.173 millimeter. So we can now compute the net tensile strain. So when we say net tensile strain, so this is the strain experienced by the steel, and its formula is 0.003 D minus C over C. Substitute lang natin yung mga values na na-compute natin. D is 435, C is 169.17, so substitute lang. And then, to get the stress in steel, so from the Hooke's law, stress is simply equal to the strain times the modulus of elasticity. So the strain in steel, we just multiply this by the modulus of elasticity of steel. If the computed Fs is greater than Fy, so meaning the steel yields and our assumption that Fs is equal to Fy is valid. So the steel yields, meaning the computed value of A is correct. So A equals 143.797. The next question is, what is the nominal moment capacity? Okay, so we will now start determining the moment capacity. So as I have said before, the moment capacity of the reinforced concrete beam is equal to the couple created by the concrete and steel. So we just have to take moment about the centers of the forces. So it's either we take the moment towards the center of the concrete or towards the center of the steel. So M sub n, so let's say we take moment about this point, about the center of the concrete. So that is simply T times the moment R, which is D minus 0.58. Recall that T is simply the force in the steel, and we have solved that as ASFY. we multiply this by d minus 0.58. So we substitute the values. We have reinforcement as 3 pi over 4, 25 squared, and then Fy is 415. Then D, we have computed this before, 435, and then A, we have computed this in the previous problem. So we have 221,905,054.8 Newton millimeter. So in kilonewton meter, 221.90. Okay, so that is letter C. Okay, next, calculate the ultimate moment capacity. So when we say ultimate moment capacity, that is the nominal moment strength multiplied by the resistance factor. So our resistance factor for LRFD for moment strength is determined by the following. So we have both equations for that. These are the values for P depending on a certain criteria. Okay, so the value of the reduction factor will depend on the value of the net tensile strength. So it is important that we compute first the value of the net tensile strength. Before, we have already computed this, and that is 0.004713990815. So we have to identify on which category does it fall. As you can see, it is less than 0.005. So therefore, it will not fall on this criteria. So possibly it falls on this criteria or the third criteria. If you're going to compute the value of Fy over E sub S, you can finally identify on which category will this strain fall. Okay? So please compute for Fy over ES. Fy is 415 and then E sub S is the modulus of elasticity for steel. So 0.002. So mas mataas yung ating strain sa 0.002, no? So therefore, we fall into this category. Okay, so by the way, we have a name for this category. So for the first category, we call this as the tension control. The second category is the transition stage, and then the third category is the compression control. Yeah, so therefore, we will use this formula in determining the reduction factor. We substitute the strain E sub T, 0.47, and then yield strain is the computed value of Fy over E sub S. So we can now compute for the value of T. So after that, once that you have computed the T, we can now compute for the ultimate moment capacity. So we just multiply that by M sub N, and that is letter D. Next, calculate the required steel area for balanced condition. Okay, so for a balanced condition, so it means that as the concrete reaches a strain of 0.003, the steel will reach its yield strain. So meaning, the yield strain Fy over E sub S will be the strain in the steel. So we will equate this in the formula of our net tensile strain. We substitute the value. Our effective depth is 435. So we substitute the value of Fy 415 and then modulus of elasticity is 200,000. Okay, so we can now compute for the value of C. Now we can compute the depth of compression block. So A equals beta C. So we can compute for A. And then we can now determine the required steel area. So we will go back to our equilibrium equation of concrete and tension steel. We have 0.85 FC prime AB equals ASFY. So I have replaced AS by AS bar because we are computing for the steel area for balance condition. So we substitute the value of A here. We can now compute for the area at balance condition. Okay, and that is letter A.